Okay, let's go ahead and jump into the next condition. Let's take a look at standard collision. We'll drop him in there. Let's delete these. Delete these. We'll create a deflector. Let's create a U deflector. Let's actually, we do need a piece of geometry out here. The U deflector, we'll go ahead and pick which object we want to use. And we're going to need to use the bind space warp to connect that deflector to TP, so TP is aware of it. And then let's go ahead and alt-right click to get rid of that and that. And now let's take a look at the standard collision condition. You can see here under the inactive deflectors, we've got the U deflector we just created. We'll go ahead and activate that so it's actually working. And then we'll go ahead and connect this output into the position born. Now what will happen is, let's actually get that piece of geometry closer. So when this particle, when he would collide with this U deflector, which is this sphere, then it's going to output a true or not. Pretty kind of standard basic condition. So you can see there, at that point, he goes ahead and collides and outputs a true, and creates some particles. And because he's going out the backside, which are non-face normals, or the opposite of the face normal, it's not going to detect that collision. If you do want to detect those kinds of collisions, you should use a dynamics, just called a U deflector, which has a two-sided option. Okay, but also what we can do here is we can take the standard collision, and we've got his position output. We'll go ahead and use that to control where these particles are born. Bang. Now you can see they're being born actually at the point of collision. If we want those particles to kind of bounce away opposite of the direction of collision, we can go ahead and use this collision velocity, which actually calculates that opposite direction. And now they'll hit and fly out that way. Let's actually increase the number of particles being born and give them some direction variation and some extra speed variation. Boom. Okay. So that's the standard collision condition. It uses existing standard max U deflectors in order to detect those collisions. And as we mentioned, there's a much more robust one called U deflector under the dynamics section, which has a two-sided option as well as collision offsets and pretty much all the standard parameters you would expect. Very, very useful. But enough about standard collision. Let's go ahead and get rid of him. And we've covered in mesh, standard collision, distance, time interval. Always true is kind of it was very useful way back in TP1 and TP2. We don't see a whole lot of it these days, partly because you don't really need